are you with us?
Yes, I am.
Good to see you, man. How are you?
Good to see you. Doing well.
You got a beautiful background. Light and the colors, man, you got it. Well, I'm stoked to see what you have for us today. I see that you're also sharing your screen, so let's see if this is working. Nice. Okay, Wes, your team.
Awesome. Thanks, Adam. So today I'm going to talk about Retrieval Augmented Generation. Our startup, Train GRC, is focused on cloud security training. And as part of our platform, we decided to build StinkBait.io, which is an application focused on cybersecurity research and reporting. In the cybersecurity domain in specific, the knowledge base is very fragmented amongst different sub-communities and even sub-communities. So that siloed approach to information sharing has really created a scenario where in cybersecurity, collecting a knowledge base is fairly challenging. Furthermore, you have this consideration that in relation to LLMs, cybersecurity topics are often censored. You'll potentially hear ChatGPT say, oh, I'm sorry, I can't do that for ethical or safety reasons. And so this creates a lot of challenges in sharing proper information in the cybersecurity space. So we decided to build a retrieval augmented generation system that could help with this, but there are some challenges that we've encountered that I think you in the audience may be interested in and you may experience similarly. The first one we have is related to data quality. So there are a variety of file types that we try to handle as part of our data processing pipeline. One of our fun and games to play on our team is it really a PDF? PDF's been around since 1993, and over the decades since, there's lots of extensions to PDFs. Various file formats that are called PDF may not actually be a valid PDF. And PDF generator plugins that are associated with various websites, they can often return invalid PDFs. Furthermore, you have PDFs that are often just poorly photocopied documents. So these various file types that all fall under sort of the spectrum of a PDF may not actually be a PDF. So why does this matter? Well, who cares if it's a PDF, right? Well, with optical character recognition, you can extract the text from a PDF, and we use Amazon TextTrack for this particular use case. However, even with a proven solution like TextTrack, you're often going to encounter an error saying that this isn't actually a PDF. Well, how do you address that? You can actually transform the PDF into a JPEG and then reprocess that file as a JPEG. So TextTrack allows for us to have sort of this backup capability to extract data from the various PDFs we may need to ingest. Then you have web scraping content. So this is one of the most common challenges that I see people face when trying to build their own data set for retrieval augmented generation is how do you actually get all of the information off these various websites? With the variety of web frameworks and WYSIWYG editors for creating websites, HTML data is actually not that well structured. So how do you get high quality data? Well, unfortunately, a lot of this looks like manual inspection of various websites and understanding the HTML elements that are most relevant for that particular website. But this is a critically important task because if you go in and look at some of the third-party or open source tools that'll help you with web scraping, and you actually inspect the data that you're getting back, you may find that the data isn't quite as well manicured as you'd anticipated. So these are a couple of the things that we see in relation to data quality. The next hurdle that we encountered was related to the search quality. So there are different algorithms or indexes that you may use in relation to doing a search result. Now, many people know that there's a difference between exact KNN versus approximate nearest neighbor searches, and that oftentimes the latency associated with exact KNN is not what you're after in a real-time application. So then you have to use indexing algorithms. algorithms. And we have, for example, IVF flat or HNSW, and now a newcomer disk ANN. Well, all of these algorithms have different trade-offs as far as recall or accuracy versus the latency associated with the request. Anecdotally, we started out thinking, hey, we'll use PostgreSQL and PG Vector, which at the time only supported IVF flat. We thought that using an open source database technology would have real benefits as we grew and changed as an organization. But when we started to see the latency results for IVF flat, it started to dawn on us that maybe we had to go a different route. Now, all of the different vector databases that exist out there, they may not support each of these different algorithms. They may only support one or a couple of these algorithms. And you have to weigh the trade-offs between, do you want to pass off the responsibility for choosing your algorithm to a vector database company, or do you want to have fuller control of it? And if you want to have fuller control of it, can you actually manage this technology in such a way as to return similar quality and similar latency of results? You also have the consideration of picking a model. So when you're picking a model, most people just choose ADA embeddings off the shelf because they're already using the OpenAI API. Well, good news for them is that the context length for ADA embeddings is very long. You can get almost 5 pages worth of document under a single embedding. And then furthermore, ADA embeddings is fairly performant. It's on the Hugging Face MTEB leaderboard. However, there are other embeddings models that may perform more positively for your particular use case. The state-of-the-art embeddings models on the MTEB leaderboard is not ADA embedding. It varies depending on what particular evaluation metric that you need to consider. Then there's also the consideration of what types of data was the model trained on. So with embeddings models, you have sentence transformers that are called multi-QA models, meaning they've been trained on short question and answer responses. Then you have MS Marco passages, which are more long-form text. Maybe you need a multilingual model or a multimodal model that'll do image and text. All of these considerations go into picking the appropriate model for doing your retrieval. Finally, the last consideration that we kind of had to address is, how do you chunk the context and how are we going to store this information longer term? So when you're considering context chunking, the ideal way to chunk your context would be along conceptual boundaries. So all of the information associated with one particular topic would go in one embedding, and all of the information associated with another topic would go in another embedding. However, what we've seen at scale is the only realistic way to chunk your embeddings, other than just sentences or, something similar to that, is to use formatting. So, for example, in Markdown formatting, you have different heading values, and you may be able to break up pieces of text based on the heading value. Well, this is sort of a proxy for contextual separation, but it is not equivalent to contextual separation. So when you're trying to re-inject your context in the generation approach, how do you ensure that the context that you're embedding is relevant? And part of this is a challenge of how are you chunking your context? So the last consideration we have here is, what do you do when you need to change databases or embeddings models? So if you're experimenting with vector databases and you think you may change your vector database, maybe you should store your vectors on disk or in blob storage, because if you store those vectors on disk or in blob storage, you don't have to recompute them later on. Then if you're experimenting with embeddings models, there are some considerations that you need to make up front here. How many dimensions are the vectors? How much space is that going to take up in your database? And then also, what source style is your data? If you choose the wrong model, you may not be able to get the results you're looking for. So thank you. That's what I have today on Retrieval Augmented Generation.
Wes, Thank you very much. I mean, there's so much wisdom packed into so few minutes. It's fascinating just to see, like the conceptual distinctions and the boundaries. I mean, on one hand, it sounds somewhat difficult. When you first said it, I was like, well, this is difficult to know. How do you even draw those boundaries in the first place? And then you're like, oh yeah, you probably already did that because of your markdown, right? Like in some way, so this is probably a useful proxy. Although I suspect that this is an area of just active research too, right? It's just like, how do you, because sure, I've marked it down in a particular way, but it may or may not be because it has a deep semantic stickiness. It might just be because I thought it would be easier to digest for the kind of people that I was talking to at the time, right? So
yeah. No, there's lots of it manual inspection, and just to throw my bid in for the MLOps drinking game today, garbage in, garbage out, right? So I know it's a cliche and everybody says it, but the reality is so much of the work that has to be done to make these models performant is done up front in that pre-processing and processing of your data. So vitally important.
Find Wes on Slack, and he's the MLOps community organizer of Austin. Is that true?
That's true. That's true.
Wes, thank you very much for coming today.
Thanks, Adam.